Hello, I'm Gordon Ritchie with Kollmorgen, and this is 2 Minutes of Motion. This video is part of our series on feedback devices, and this session is on the Hall effect device. It is a very simple device and is used in motion control to provide everything from course, rotor position, to end of travel limits. What makes the Hall effect device so surprising is that it was discovered by Edwin Hall in 1879 while working on his doctoral thesis. The significance of this is that the transistor was not invented until 1947. In motion control, we will use Hall effect devices in conjunction with other feedback types, such as TTL incremental encoders, to prevent having to find the rotor position through a technique called wake and shake, in which the motor makes a series of step-like moves. Inside the motor, the Hall effect sensors are aligned with the motor's back EMF. Since the magnetic field passing through the windings is what produces the back EMF, the Halls will provide an output telling the drive when the magnets are aligned with the windings. This is only a coarse positioning of the rotor, used to prevent wake and shake. Outside of the motor, Hall effect sensors can be used for home switches, end of travel limit switches. Because of the way the Hall effect devices work, it requires only adding a magnet to the actuator. In most cases, this is added internally, specifically to trigger the sensor. The genius of the Hall effect device is how simple it works. Edwin Hall's original design was based on the Lorentz effect, which describes how electrons flowing through a material, in Hall's case a thin layer of gold, will have the electrons effectively pushed to one side of the material or the other, creating a difference in potential between the two sides. The side to which the electron flow will be pushed will depend on the magnetic pole placed perpendicular to the material. Because of this effect, the Hall effect device is a unipolar device. In most cases, we're only concerned with detecting one pole or the other. While the output of the Hall effect device is a linear function of the magnetic field potential, internal circuitry allows the output to trigger to saturation when the magnetic field is detected. This basically turns the Hall effect device into a magnetically triggered switch with an output that is either on or off. The Hall effect device is a versatile element with many different applications. For more information, check out other 2-minute motion segments or sign up for one of our classes at